Okay, so anyway, again, you can think of a series as just one like column of a table. The data frame basically expands so you can have multiple series or multiple columns, right? Okay, so here's that. I'm basically setting up something from scratch. Okay, so I'm basically wanting to list out a bunch of info about different courses. So this is the prefix. These are all geology or geography courses. So this is a list of strings. And then I have their associated numbers. And then I have their associated titles. Again, these are all just lists. And then I basically merge all those into a dictionary of prefix, course number, and course names. So these values, prefix, CNUM, and CNAME, are coming from the lists up here. And then once I have that dictionary, I use the pd.dataframe function to convert that into a data frame. And if we print that, we end up with something like this. Okay, and this looks like, again, like what you would think of as an Excel spreadsheet. So we have the column name, which came in this case, came from the properties there in the dictionary, and then obviously all the associated data. No, we didn't assign a row in, we didn't name the rows or provide an index for the rows, so they just got the default, which is numeric values from 0 to the number of records, right? So basically now we have a data table. Now let's look at doing some subsetting from a data frame as opposed to a series. So if you grab like one element here, then that pulls all the, in this case, course names, so all the data from a specific column, right? We didn't get back one thing because all of these rows are associated with that column, right? That course name column. Here I'm pulling out two course names by just providing a list. Note that you can be a single value. If it's multiple values, those need to be fed in as a list. So that's why there's two sets of brackets there. It's basically a list within the bracket notation. So here I pulled out two columns, the course number and the course name. Okay, and then another way to do this, if you want to use the names, is with the lock method. So this is a method that's applied to a data frame. So here I'm pulling out the first, second, and fourth rows, and then just these data. So let's see what that looks like. Yeah, so here is that. So it was the first, so geomorphology, the second, paleontology, and the fourth, GIS science, right? So this is a subset of the rows, and then this is a subset of the columns by name. We didn't use names here because the rows don't have names, right? And then another way to do it, instead of the lock method, is the Ilock method. And Ilock method is using the indexes as opposed to the names, right? This is allowing you to use a mix. So here we use the indexes and here we use the names. But here, now we're using the positions as opposed to the names, right? So go back to our table here. This is 0, 1, 2. So basically, we'd want 1 and 2, right? So extracting the rows at index 1, 2, and 4, and then columns at index 1 and 2, right? So let's just swap that out, and this should give us back the same result, right? Okay, so in summary, for subsetting out rows and columns, you can use lock. Lock is going to accept a mix. You can use indexes, or you can use the names. Actually, really, what you're using are names, is because these actually are the names, 0 through the number, the values. So these are using the names, and then the iLock uses the indexes. So that's the difference between lock and iLock. Okay, so here I'm adding a new column to an existing data frame. So note that if you do this, if you try to add a call or add data into a column, the column actually doesn't have to exist beforehand. So this column full name doesn't exist. It's just going to be created dynamically, as it's created, or as this code is executed. So what I'm doing here is I'm basically trying to concatenate the name together. So I take the prefix and the course number and the course name, and I add some spaces there and a colon, and that's going to print into a new object. Note the use is this dot map and then str, dot map str, dot map str. What that does is dot map is basically used to apply the same operation over like each row in this case, in the data. So if we run this, now we have a new column, and this is the full name that's been concatenated into a single string, right? So again, full name didn't have to exist beforehand. All right, so generally you're not going to create data from scratch unless it's like something tiny. You're probably going to want to be able to read in data, right? So there's already in a tabular format. So examples include things like Excel spreadsheets, CSV files, the attribute tables of like geospatial data layers, tables from databases, things like that, GeoJSON JSON files, things like that. Okay, so anyway, here's some data that I have on my local disk. It's, as you can see, here's a CSV file. So I'm reading in I'm using read underscore CSV, which is a function from Pandas to read the CSV file. I'm telling it that the comma is used as a separator, and then the header is equal to 0, which should mean that there is a header. And then I also put in the encoding. This isn't always required, but sometimes there will be issues if the encoding is misinterpreted. I found with this data there was an issue, and I had to actually provide the encoding. And then here I'm using this .head method, which just prints the first 10 rows of the data, or however many values you put in there. Okay, so here you can see what this data looks like. So basically, this is a data frame of movies with a couple different columns. So we have the name of the movie, the director, the release year, a person's rating. This is actually a data set my brother created, so this was his rating of the movie, the genre of the movie, and then whether or not he owns a copy of it. And then here I'm running length on the data frame, and if you run length on the data frame, what it does, in the wrong one, it spits back the number of rows. So in this case, there are 1,852 records in the table, so he has 1,852 movies in the data set there. Let's just have a look at that data before we move on, just like in another environment. So I'm going to go to that object. So it's in my D drive, data, and then Matt's movies. And by default on my machine, this is just opening up in Microsoft Excel. Okay. Alright, so anyway, you can see there's that same data in Excel. This is actually a CSV file, so if you just open it up in a plain text editor, so I'm just going to do open with, and then we'll just open it with Notepad. This is the actual structure, right? So it's a bunch of data separated by commas. And then that can be read in and turned into a table. In the case of Excel, it basically becomes a spreadsheet. In the case of Python and Pandas, it becomes a data frame. So now we're going to play around with doing like data subsetting and data querying using Pandas. And we're going to mainly stick with using this movies data frame. Okay, so in this first example, I want to create a data set that is just the drama movies. And here's the syntax for that. So this is the name of the movies data frame, which was created above. And then we basically want to only extract out the rows where the genre column is equal to drama. So you can see that there. So data frame column in data frame is equal to drama, and that'll spit back again just the dramas. And here again, I'm just printing it and getting the length and everything. In this example, I'm getting back all the movies that are drama and that have a rating greater than 9.0, right? So similar syntax here. The only thing we did here was add in the and, because we have like kind of a compound query, but everything else is effectively the same. Excuse me. And then lastly, we have now I'm subsetting out the columns along with the query. So by default, you get back all of the columns, and then the rows will just be the ones that meet the query. So just the dramas, or just the dramas that are above 9.0. Now in this last block here, I'm spitting out just the movie name and the director. So this first block is basically the subset of rows. And then the second block, which is basically a list within a list, or a list within square brackets there, is the subset of columns, and we're just grabbing them based on their name. So if we run that, we can see some of the subsets here. So these are all the, this is a subset of the first 10 genres. Anyway, so if you want to get the lengths, this tells you how many was in each one. I'm just gonna not show these print statements take up a lot of space, so I'm gonna not show that, and let's just get the lengths back. Oops. Actually, that's what I wanted to do. Let's see. That should just give us back the two lengths, I believe. There we go. So there were 321 dramas in the data set, and then there were 23 dramas that were above 9, right? What if we wanted to get like the percent of the data sets that were like dramas, for example? Well, how we could do that, let me just add another block in here. We could get length of just dramas, and we'll divide that by the length of the original data set, so movies data frame. And then let's just, to get a percent, we'll multiply the whole thing by 100. So basically the number in the subset divided by their total number, original number, multiplied by 100. Oop, something didn't work. Oh, I see what I did. I screwed up my brackets. So, and then we still need to put in a second pair, I believe. There we go. So 17.3% of the movies were in the drama category. Okay. Here's just a few other examples. And now instead of using this method, which is a lot of this like bracket notation, I'm using the .query method that's available in Pandas, which can give you back the same result, but the syntax is a little bit more concise. One thing I found when I use the query method is if you have spaces, like in column names, it can mess it up. So the first thing I'm doing here is I'm replacing any spaces with an underscore. So this is list comprehension. So basically perform this, replace empty spaces with underscores for every column in the movies data frame. So I'm doing that because these types of things will fail sometimes if there's spaces. So that's okay. And then now here are the queries. So genre is equal to drama. Genre is equal to drama, and my rating is greater than 90. Again, these are much more concise. And then down here at the bottom, I did this with the query, and then I still did the same thing to subset out the columns with the bracket notation, so kind of combining them there. A couple things to note here, there's quotes around the text here, so I use single quotes to wrap the entire query statement so that there's not ambiguity. Yeah, but anyway, this is just another way to do it. So if we run this, again, that gives us back our results. The same thing, just a different way to do it. Note if you do this, this 2CSV is another Pandas. In this case, it's a function that can be applied to a data frame, and this allows you to write the result back out to disk. And I think I had this already, so I'm just going to put a 2 on the end. So if I run this, and then if I go into my folder there that I wrote it to, so it was D, data, Matt's movies, sub 2. We get back our subset of movies there, that query criteria. So it's pretty easy to read in and read out CSV files. Just as a note, if there's other types of files that you want to work with, like Excel spreadsheets or database files or whatnot, there are lots of different input reading functions. So you just have to look at the Pandas documentation and see what function you want to use to read in a specific type of data. And again, generally we're talking about data that's in the form of a table.